Welcome students to the series of lecture on building the LLM model from scratch. And today we are discussing about vector embedding. In the last session, we discussed about tokenization. Yes, that is important. That is critical. Why? For a very simple reason, because machine only understand number. So what we did, we took tokens and converted those tokens into number, right? So these are the tokens, and we converted these tokens into numbers. Perfect. But does it carry the semantic meaning of the word? Does it? Or is it just converting the tokens or word into numbers? For example, if I say that cat is a pet, but lion is a pet or not, that's a question, but dog is a pet. I converted it into tokens, ID or numbers, that is 23, 1, 120, 50, 1, 120, and that will become your vocabulary. Mapping of the tokens with the token ID is what? Vocabulary. But can I use it to provide certain semantic meaning to the algorithm, to neural network or attention mechanism or machine or my Python code? And will it be able to perform the task properly? Because see, I'm saying cat is 23 and A is 1, lion is 50, and say dog is 150. How it is capturing this information that cat is very near to pet or pet is very near to dog and lion is not near to pet or it is an animal? How we are capturing these information? We are not capturing any information related to the semantic of the word, related to the meaning of the word. So the semantic, the meaning is lost. Yes, we have converted the words into number. Awesome. But what about meaning? What about the context of the word? Not of the sentence, because that is context embedding. We'll talk about that later. Of the word. So for that, the simplest approach is what? For every word, we need a different feature, different characteristics of the word. For example, we write cat, lion, dog, blue, sandwich. These are the words. And we want to know that how we can capture the semantic or the nearness of the word. How we can capture the semantic or the nearness of the word. That cat is near to dog if I compare cat nearness to the lion. So how would I do that? So we can do it by writing all the characteristics that a word can have. For example, we can ask the question, is it animal or not? Is it human or not? Is it a pet or not? Is it a color or not? Is it edible or not? Does it have four legs? Does it have two legs? Does it have one leg? And we can keep on writing as many as characteristics or dimensions, characteristics, features, or dimension that we can think of, right? In this universe, we can divide this whole universe, whatever the words we have, into different dimensions. We can keep on writing infinite dimensions. Right now, I have written some dimensions. So is cat animal? Yes. Lion is an animal? Yes. Dog is an animal? Yes. Blue is not an animal. Sandwich is not an animal. So and so forth. Right. But see, there's something weird happening. If you talk about pet, it's tick, and it is also tick. It should not be ticked, right? It should be crossed. But what about like Dubai? Definitely, the percentage of lion being as a pet or treated as a pet is too low. But yes, some people have. So what should we do? Is this yes or no, right or wrong, one or zero? Is it perfect? Is it everything is like yes or no, black and white? No. Also, let's ask this question, edible. Cat, lion, dog. From the perspective of whom you're asking this question? Edible. Are you asking this question from the perspective of lion, that a cat is edible or dog is edible or not? So what we should do, should we not use weights? There is a highest chance or highest possibility of cat being treated as an animal, right? So let's put down the weight of 90. Lion is also an animal. Let's put the weight of 90. Dog is also an animal. Let's put the weight of 90. Blue cannot be animals. It's a very small weight. What about pet? The chances of dog being a pet is very high. So 99. What about cat? It is also pretty high, 89. But what about lion? Let's reduce the weight and make it like 30%, 20%, or 50%. Edible. Yes. The highest probability of anything getting edible is what? Sandwich. But blue is a color, cannot be edible, so very low weight. Then cat, lion, dog, you're assigning certain weights. And these weights will help to capture the semantic, the capture the nearness, the capture the meaning of the word. And the lowest the difference between the weight for all these characteristics, for all these dimension, that will define the similarity, that will define the nearness. And this is called as vector embedding. Whether you call it as characteristics or whether you call it as dimension, it is up to you. These are dimensions or characteristics in which you're defining the weights of a token or a word. Definitely, word is not equal to token. We have studied it in the byte pair encoding. But this is the whole logic that why we have vectors, why we have vector embedding. It is simply telling you that, okay, there are 4 to 5 dimension on which we are defining a word. That's all. Cool. So at the end, what we have to create, at the end, we have to create vocabulary. Vocabulary is converting the tokens or the words into digits or numbers. And then for each digit or each token, I should have different dimension, different characteristics, and I have to assign weights. So what I need my token IDs. I need my different characteristics or dimensions, and I have to assign weights, right? This is what we need to do. How to do it before how to do it? Important question is, what about the different models that are well trained model? How many vocabulary they had? So in GPT-1, we had a vocabulary of 40,000 words. And for each word or each token, there were 768 dimension, not 4 or 5 dimensions, 768 characteristics were written. Like, is it a pet? Is it an animal? Is it human? Does it having 4 legs? Does it having 2 legs? All these dimension. In GPT-2, the number of vocabulary they were playing was 50,257, and the dimension from the smaller model to the largest model, it is 768 to 1600 dimensions. And GPT-3, again the same number of words, but the dimension was in 12,000. So for every token, there were 12,000 characteristics or dimensions were written. And for each word or each token, you had to assign 12,288 weights for all the different dimensions. Now, what is the approach? How to do it? A very simplest way to create this vector embedding is you take your tokens or token ID, you take your dimensions, and just assign any random weight. That's it. And based on that, try to do some prediction. These weights are random. So definitely there would be error in your prediction and the actual behavior. You calculate the error. You try to find your loss function or your gradient, and you try to optimize your weight. And you keep on repeating this exercise till you get the most optimum weight. Okay. Now, in GPTs, these are done at the attention level. So when you have started training the model, then you assign the weight. So what are the steps? Tokenization is step number 1. What is the step number 2? Vector embedding, then positional embedding, then contextual embedding, then self-attention. And there you're training the model. So when you have started training your model, these weights were optimized. So when the vector embedding is created in GPTs at the time of pre-training of the model, however, you can also have pre-trained weight for vector embedding before you start your self-attention step. You can also do that. Okay, so we'll try to develop our own method of vector embedding. But before that, let's have a look. What is already available there? Like, do we have any good library through which we can like fetch out the different dimension or different weights of a given word? And can we play with it? Can we find the similarity? Can we find the combinations of word or combination of words generating other word? Can we do that? So for that, we'll use word2vec library. So we will be using a library developed by Google. So the library is word2vec. Okay. And it has 300 dimension. And let's try to understand that how you can play with this word2vector. So word2vector have near about 3 words, and for every word there are vectors or vector embedding or weights assigned. So we'll see that in a minute. Okay, let's see that how many words it is trained on. So these many words we have. What are the size? The dimension is 300 dimensions. So how many characteristics for each word? 300 characteristics for each word. So you can think of like 30 lakh, it's 30 lakh words, and each word has 300 dimension. And let's try to find out that what are the first 10 words or 11 words there. So these are the words. Now let's try to find the vector that is assigned for a given word. Say, what is the vector for cat? So the vector for cat is this. So these are 300 weights for different dimension. And what is the shape? 300 dimension. What about dog? This is the weight. Can I use it to train my model? Yes, you can use to train your LLM model. Now, let's try to find out if it can find the similarity with a combination of word. For example, I have yen and I have subtracted Japan from yen and adding India. So what should be the result? I think by now everyone has guessed the result. So the result is it's calculating. It's trying to calculate the difference between all the vectors, all the weights of the vectors. Okay, you can see that the result is rupee giving a percentage of 61.9, then again rupee, then rupees, then Indian rupee, and then it started hallucinating. Whatever, but it tried to give you the the most nearest answer to this question. But does it work every time? It depends upon whether it was trained on every word or not. What is the problem here? Why it is throwing error? Because it was not trained on the word Bill Gates. And that's why it is saying key Bill Gates not present in the vocabulary. That's it. So it is necessary that you create your own vector embedding depending upon what you're trying to train. Is it a financial data? Is it like generally the words like GPTs? What you're trying to train. And that's why it is necessary to understand the algorithm to like create the random weights, to predict, find the error, make a loss function, and then optimize the weight. Okay. We'll also try to find out the similarity between two words. We'll also try to find out what is the similarity score between two numbers, two words. So for example, I want to know the similarity between king and queen. And you can see that it is giving me the similarity of 65%. What if I change it to say king and a man? What is the similarity number? S- Okay, we have to restart the kernel. We only need this. And we are trying to find out similarity between two words. Okay. So it gave a score of like 22%. So there is no similarity between a king and a mango man, a common man. Okay. So the similarity of king and queen is somehow. So the similarity between king and queen is higher than king and a man, king and a common man. Okay. So this is one of the vector embedding that we have used that is already available. That is Word2Vec by Google, which only have 300 dimension. You could need like 10,000 dimension because higher the dimension, yes, it is better that your model can predict. Yes, there is a caveat to this statement, but in a very simple term, what I'm trying to highlight is at the end, we have to develop our own vector embedding. We have to develop our own dimension. We have to develop and think about our own weights. Currently, I'm just trying to give you a sense of that. What is vector embedding? Can you use any library which is already existing for vector embedding? The answer is yes. But if you're trying to optimize your own LLM, then you need to develop your own vector embedding and vector embedding dimensions and vector embedding weight. With that, I'll take a pause. Thank you. Have a nice day.